Now, I want to try to demonstrate why Dataiku and Snowflake are better together. As we discussed earlier, Snowflake can be a great partner with Dataiku. So for those who may have or have not seen Dataiku before, this is the view from the Dataiku homepage itself, where in this view, we can see the projects we have created before. For the demo project we will look at later, it is the credit scoring project, where in this project we will use data from Snowflake and others. Then, here is the view of the project homepage, where in this view, we can see the metadata of our project. Such as in this project, we have 12 data sets, we have 12 recipes, and also we have one model that we have deployed into our project flow. To look more detail into our flow, we can press this Go to Flow button. Then here is the view of the flow. Let me enlarge it here. Here is the view of our flow, where our flow can be seen from left to right. That flow, the flow we are seeing now, is created automatically by Dataiku itself, depending on the recipes we used before. For the data source we are using now, we are using two data sources, where these two data sources we get from Snowflake. The first data set, we use unemployment data, then we also use launch data here. First thing I want to mention here is in creating a project, a machine learning model, or anything like that, one thing we need to know is the capability to move our data source into this Dataiku environment. In Dataiku, we can input our data source from SQL databases or cloud storage, or OneDrive FTP, or HTTP. For SQL databases itself, of course, we can connect from Snowflake, Databricks, Google BigQuery, MySQL, and so on. Here I want to mention that the connections we can see here are the connections that we have already created and integrated with our Dataiku environment. For SQL databases themselves that can already be integrated with Dataiku, there are many, for example, like SQL Server or Oracle, Hive, and so on. Then in creating a data analytics project, a machine learning project, after we successfully move our data from our data source to the Dataiku environment, the next thing we need to know is how we can prepare, clean, or manipulate the data we have moved into our Dataiku environment according to our project and our needs. To manipulate it, of course, we can use the available recipes. In Dataiku itself, there are two built-in recipes provided by Dataiku, where the first recipe is the one in yellow here. This recipe is intended for non-coders, people who are more inclined not to use coding, where for this recipe, we usually call it visual recipes. Then for the second recipe, we can aimed at coders, aimed at people who are more comfortable or more familiar with coding, such as Python, R, or SQL, and so on. For example, in our current project with two data sources that we have, the first thing we want to do is to join these two data so that we can perform more in-depth advanced analysis related to our data source. To use this join recipe, the thing we need to know is that we need the first and second data sets we want to join. After we find them, we can choose the join type provided by Dataiku, such as left join, inner join, outer join, and this is quite complete. After that, like previous joins or in general, Dataiku will automatically help us determine the join key from column to column. Here is an example. It's the loan ID. If, according to us, the join key provided by Dataiku automatically is not enough, we can add a condition here. For example, there is a term or another employment term, for example. Well, these two data sources, these two columns, can be determined as the join key for these two data sets of ours. Then, if we feel we need to join the third table, we can press the Add button here, plus then we can choose the data set we want to join next. For example, the data is loan data prepared, then we add the data set. As I explained earlier, this join key is provided automatically by Dataiku itself. If we feel that what is provided by Dataiku is incorrect or there is something wrong, we can delete or add according to our needs for each data set. If we have joined and there is a column or table that we feel is not needed for the join, we can delete the table here. One thing I also want to mention here is the selected column, where Dataiku itself, by default, it will select all columns from both our data sets. If, according to us, this term column is not needed, we can easily uncheck the column like that. Then one thing I want to mention in general is that to do this join using two very large data sets, it will definitely require powerful compute, large compute as well, so that this join does not take a very long time. If you do only one join job, it takes about 10 minutes or 20 minutes. It is considered very impractical. So Dataiku and Snowflake think about how to solve that problem, where we use the database here, and Dataiku will convert our configuration into a query. And the query created by Dataiku will be sent to Snowflake, and Snowflake will run this query natively in the background of Snowflake itself. And even if, according to us, it feels lacking for the performance of this join, even Snowflake and Dataiku have very good collaboration features, where we can easily change our compute warehouse. For example, from the previous small one, we can change it to a large warehouse. Then we can also change our Snowflake role. With just needing to write a variable like this, we only need to select the warehouse and roles from the Snowflake we have. And what happens if we choose or configure variables like this? So, for this join recipe specifically, it will use the large warehouse. This does not configure for all flows or all jobs before or after. This is only for this join recipe. So what I want to mention here is the capability of Dataiku and Snowflake to easily change our compute engine like that. Then after that, Snowflake has a feature called Snowpack, where the Snowpack feature is the first partner feature that can easily use. Snowpack is Dataiku. We can use it from the existing Python recipes in the previous code recipes. We only need to use import Snowflake, and all Snowpack functions can we use like SnowDF, SnowPandas, and others. And for some people who are more familiar with the notebook development environment, Dataiku also provides that feature where we only need to press the Edit in Notebook button, and Dataiku will convert our code and adjust it in notebook form. So I know that some people prefer to use a view like this, that we can configure or debug each step that exists. Then, in addition to Python, Dataiku can also use SQL recipes, where users who are more familiar with SQL code can use that code in Dataiku. Here I want to mention that to create a project, the whole project requires many stakeholders, such as from the business team, from the dashboarding team, from the BI team, from the reporting team, or from the operation team, the data analytics team. We need all those roles to complete a project. Here is a very emphasized feature of Dataiku, that the collaboration feature can be carried out in Dataiku by providing visual recipes and code recipes, where I mentioned earlier that code recipes can be used by non-coders and code recipes can be used by coders, like that. Then the thing I want to mention in Dataiku is the so-called prepare recipes, where we as data analytics or data science need quite a long time to analyze or manipulate our data. Here Dataiku provides recipes features where the picture is like a broom. Here, the goal is from the prepare recipe feature. Dataiku provides many library processors, such as filter data or mathematics or geography. RC, for example, like creating an area, reverse geocoding, and so on. In the prepare recipe, we can also delete columns easily. For example, for the open account column, for example, if we feel that open account is not needed, then we only need to right-click on this column. Then we can delete. And Dataiku will create a remove column processor and will be selected as remove like that. If we feel that it is enough for the prepare, we can run it here, like that. And all these computations, like previous recipes, Dataiku will convert all the steps that we created earlier into a query and will be executed in Snowflake using the Snowflake engine like that. And the very intuitive feature in Dataiku itself is AutoML, where Dataiku provides one AutoML feature. such as auto-clustering or auto-prediction or auto-time series, and so on. We only need our training data. For example, this is our training data. Then we choose lab. Then we choose, for example, auto-prediction. And for the target column, we have is loan status. Then we choose quick prototype, and we enter our analysis name. Then we create, and the display will be like this, where there are two tabs. Later, there will be design and result, where in design, we can design how we make our machine learning. There is the prediction type, the target column, then there are the target classes, our trend test, then matrix, and feature handling, where in feature handling, we can choose what features we want to use to make our machine learning model. Then there are algorithms provided by Dataiku, such as LED GPM, XGBoost, and others like that. After we finish with this configuration, we can immediately train our model, and the result will be like this, where for this session we just made, there are 4 algorithms that we use, where in LightGBM, if we look, there is a trophy image indicating that the LightGBM score is the best score from the models we made before. To see more details, we can click on the model name. Then here is a summary, model ID, model type, then metadata we use to make this machine learning. Then here also provides feature importance, which explains what features explain or become key points for our machine learning or our machine learning model. Then there is a confusion matrix here, wherein the confusion matrix also explains that accuracy, precision, recall, and F1 score. If you need information about it, you can see that Dataiku provides information about what precision, recall, F1 score, and accuracy are. One thing I want to mention regarding the creation of machine learning models is that accuracy is not everything. To determine if our model is the best model, we need more than the confusion matrix. We need the business team. Whether this model is the best or not, then we also have to understand whether our model is taboo or not, like balanced or not like that. So we need to know that accuracy is not everything like that. And even 100% accuracy should be considered bad, that it can be too good to be true like that. After we choose which models are suitable for our use case or our project, we can deploy it into the flow. And we can update existing or deploy as a new retrainable model like that. And in our flow, icons for train and models will appear here. After we have deployed our models, we can move on to the next stage, where we will do the scoring stage. We do the scoring stage by using our score data using the score icon here. After we choose the score, and we choose our score input, data, set here. And in the configuration for our scoring, the engine used by Snowflake is for making this scoring. Snowflake will convert it from Dataiku into Java UDF, so the performance and results will be better. After we get the results of the scoring here, the next thing is that we want to deploy our project into automated training or automated flow like that. We can use this automation as a scenario, or use a scenario or auto-trigger, and so on. Dataiku also provides real-time deployment features using API, where the model that we have trained and deployed, we can deploy as an API here. We only need to enter the API service ID name and the endpoint for our API like that, and we can go to the next stage for further discussion about this deployment.